Hello everyone, welcome to the computer class. Today we are going to start chapter 13, recursive functions. The objectives of my today's topic are: you will learn recursive function and its base case, use of memory stack in a recursive function, a function calling another function, a function calling itself, features of a recursive function, comparison between recursion and iteration, programs on recursive functions. Students, please open your book at page number 339. Let us discuss some of the key terms. Number 1. Recursive function. A special kind of function that makes a call to itself. It means a function that calls itself again and again. That function is known as recursive function. Next is base case. A condition in a recursive function that helps in termination of the function. If the base case is not present in the recursive function, it will lead to the infinity state. Next is recursive case. The statement which enables the further call of the function within its body. Only in this case a function calls itself again. Our next topic is use of memory stack in a recursive function. Students, what is a stack? A stack is a pile of objects. So here, memory stack refers to a pile of objects or files that are stored in computer's memory. A recursive function uses the memory stack to store its intermediate values. If a recursive function enters infinity, then a runtime error occurs which states stack overflows. Students, stack overflow is a condition when we can't insert any object into a stack. For stack overflow, let us consider this picture in which this is a stack, means a memory stack, in which we are placing our data. When our stack becomes full, then the condition occurs, that is stack overflows, means we can't insert more data into the stack. The next topic is a function calling another function. We had done in the previous chapters that a function can be called from another function. The function that calls the another function is known as superfunction, and the function which is called is known as subfunction. So this is the example code. In this is the main method in which a function is there, name fn test1, and after main method we have declared this function with its definition. This is known as function definition and this is known as function call. So in this example code, the control goes to the subfunction when it is called, and when its code is completed, it goes back to its superfunction. The superfunction carries on with the rest of its code after the function call is over. So here fn test1 is subfunction and main is the superfunction. Let us do it practically with the help of a BlueJ program. Now here in BlueJ I am going to show you how a function calls another function. So I have created a program named call. Select the code and start typing public class call. Then first I can declare main method public static void mean, and here I'm going to call the function named sum. Then I'm going to create a function public static void sum brackets, then int a is equals to 5, enter, int b is equals to 10, enter, int c equals to a plus b, then system dot out dot println, in bracket I will write down c, and my function is created. Now I will close my class, compile the program, class compiled, no error, minimize it, right click and click on void main. So the answer is 15. So students, in this program, sum is the subfunction, this one, and main is the superfunction. So we can call one function from another function. The next topic is a function calling itself. Now, this is the case of recursive function, in which the function becomes its own super and sub function. Let us see this example code, in which a function is there named FNREC1, and there is the argument list A. And in the same function means in its function body we are calling the same function again. This is known as recursion. Now in this example code, the control goes to the subfunction when it is called, and when its code is completed, it goes back to its super function. In this case, FNREC1 is both superfunction as well as subfunction. The superfunction carries on with the rest of its code after the function call is over. Now, let us understand this concept of recursion with the help of a BlueJ program. Now, here in BlueJ, I am going to show you the program related to recursion. So, I have created a class named rec. Here, I'll type the code Control A, public class rec, and then I am going to create a function public void, let the function name be rd, in bracket I will pass any number int n as a parameter, bracket start. Now here I will write the condition. If n is greater than equals to 0, then return, and function is called rd n slash 10 semicolon system dot out dot println, in bracket let it be plus n mod 10 and bracket close. Now this is our function name rd, and my program is over. Now here I'm going to call this function in my main method. So public static void main bracket, then main bracket start. Here my function name is rd. I will pass any number over here. Let it be 2436. Bracket close and semicolon at the end, and then my main function is closed. Now compile the program. Class compile, no error. Minimize it. Right click and click on void main. So answer is 2436. Now students, see what we have done in this program. This is the case of recursive function. So here what I have done, this condition if n is greater than equals to 0, this is known as the base case. And this rd n divided by 10, this is known as recursive case. When my number 2436 is given as input, the condition will be checked 2436 is greater than equals to 0. Then it will return and this rd n by 10 will be performed. Now on dividing 2436 by 10, we get the quotient 243. But we have to print the remainder. N mod 10. The remainder will be 6. So the 6 will be printed as first output. C. Then the second case, again the rest of the number 243 will go as input. Then again the condition will be checked and 3 will be returned. Then 4 and then 2. Now students, you can see while on dividing, we are getting the quotient and the remainder. The remainder is stored as 6, then 3, then 4 and at the last 2. But my answer is like 2436. Why? Because these all operations are performed on a stack. Stack means a pile. Now, when you start keeping something in stack, the thing that you placed at the last will be removed first. So, similarly, here is the case. Similarly, when the number 2436 is divided by 10 with the help of recursion function, the remainder moves into the stack. Here, first 6 will move, then 3, then 4 and at the last 2. But when we will pop out the element, 2 will be the first element to popped out. So, this is the case when the result will be like first 2, then 4, then 3 and at the last 6. So, the output on the terminal window is 2, 4, 3, 6. The next topic is features of a recursive function. Number 1. It makes a call to itself with a change in the arguments. Arguments are the input to the function. Number 2. It terminates when it reaches its base case. Base case is the condition which helps a recursive function to stop. Number 3. In case of memory shortage, it gives an error stack overflow. Number 4. Each recursion performs a fresh memory allocation for its arguments or variables. Number 5. Memory requirement of a recursive function is high. Hence, the system cost also becomes high. because in its memory requirement, it makes the use of stack. The next topic is difference between iteration and recursion. Iteration means looping. Number first, iteration is used to perform repetitive tasks. When we want to repeat a set of statements again and again, then we make the use of iteration. Recursion, it is used to perform recursive functions. In iteration, first the calculation is done and then the control moves ahead. In recursion, the calculation is done after the base case is reached. In iteration, space requirement is less. In recursion, space requirement is more. In iteration, space and time complexity is less. In recursion, space and time complexity is more. Let us consider an example of iteration and recursion. In this example, we are going to calculate the factorial of a number. Factorial means if we want to calculate the factorial of a number 5, then we will do 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So the answer is 120. So in the case of iteration, we will make the use of loop. In fact, in bracket int n, fact is the name of the function over here. Then the loop begins. Int j is equals to 1, j less than is equal to n, j plus plus. Here n is the number whose factorial we are going to calculate. Then f equals to f multiplied by j. So when we are doing the same program with the help of recursion, its example is in fact int n in brackets. Here fact also is the name of the function. Then we are making the use of the base case. If n is less than is equal to 1 is the base case, it will return 1, else it will return n multiplied by fact into n minus 1. N minus 1 means, let's suppose the value of n is 5 in the beginning. Then 5 multiplied by n minus 1 will become 4. Then similarly again n minus 1 will become 3. So it will go up to 1 as 1 is the base case. We have already discussed that base case helps in the termination of the program. So this is the difference between iteration and recursion. Now let us perform one more program related to recursion, in which I am going to calculate the sum of n natural numbers. Here in BlueG, I am going to create a class named recursion to show you the recursive function to add n natural numbers. So here public class recursion, then I will create main method public static void main. Then I'll take a variable over here int r1 equals to 0. Then I'll call a function name add, in which I'll take any parameter, let it be 5. Then I'll print the message system.out.println result of add 5 is then r1, the variable in which I have stored the function. Then I'll close the main method and I will make my function public static then int add. This is the name of the function in which I'll pass a variable name n. Then if base case will be there, n is less than equals to 0, it will return 0. This is the base case. Else it will return n plus add in bracket n minus 1, like 5 plus 4 plus 3 plus 2 plus 1. This is the recursive call, and in this way I have finished my program. Now I'll compile my program. Class compile, no syntax error. Minimize it. Right click over here, void main. The answer is the result of add is 15. Now if I want to see that how it has added the numbers, so for that what I will do, I will print one more line over here, system.out.println. Here I will print the value of n, and then space num. Let us see. Control K, minimize it, then right click over here, void main. Now the output will be like 5, 4, 3, 2, 1. Means it has added 5 plus 4 plus 3 plus 2 plus 1. When it has reached the base case, then the stack will pop out the elements and add the elements, and the answer is 15. Now let us discuss the working of this program in detail. So here is the explanation on page number 342 of your book. Assume we call the function with n equals to 5. Then this function will work as follow. Now students, there I have taken the function name add. So what it will do? 5 plus add 4. Then it will move to the next step. 4 plus add 3. Why so? Because we have written in the recursive call n plus add minus 1. That is n minus 1. So n is 3, n minus 1 is 2. Next time n becomes 2 and n minus 1 is 1. So it will work till n is less than equals to 0, which is the base case. This is the first way. And the second way is when the recursion ends, the calculation takes place backwards. So here it is add 5, then 5 plus add 4, then 5 plus 4 plus add 3, 5 plus 4 plus 3 plus add 2, 5 plus 4 plus 3 plus 2 plus add 1, 5 plus 4 plus 3 plus 2 plus 1 plus add 0. Now add 0 will return 0 because it is the base case where n is less than equals to 0. We have mentioned in the program it will return 0. So at the end all the numbers are added and result in 15. Students, do practice these recursive functions programs in BlueJ. Thank you.